Now, but what we are seeing here, we are talking about the addition of alkyl halide to the alkene. So alkene plus HX will follow Markovnikov rule and it gives rise to alkyl halide called as a haloalkane. But it is a method to prepare haloalkane. But here Markovnikov rule means what? It is my definition. Positive part of attacking reagent attaches itself to that double bonded carbon which have more number of hydrogen. So beta that positive part will attaches to that double bonded carbon which will have more number of hydrogen and it is applicable for what beta? Unsymmetrical alkene. Sir, what is a symmetrical and unsymmetrical example here? This is symmetrical. How you know? Break a bond, same carbon, same hydrogen, symmetrical. Addition of hydrogen halide. But either you take the pi bond on this side or this side. If you take the pi bond, this pi bond on this side, it will get negative and H plus will attack on here. I'll get CS3. But a C positive will take it the Cl minus. I got ethyl halide. Correct? Take a screenshot beta here. Up to here, take a screenshot. Now we'll go for further. Unsymmetrical, I want to show you. Is it clear? Right. Now, sir, I want to show you the unsymmetrical alkene here. Unsymmetrical alkene means CH3, CH double bond CH2. Unsymmetrical. Sir, it is a double bonded carbon. But I want to add hydrogen halide. Check it, beta. This and this may. But there is a two possibility. Whenever you want to follow Markovnikov rule, remember it will form carbocation reaction intermediate. But whenever it form carbocation, it undergoes rearrangement and afterward attack of nucleophile takes place. But in this case here, my rule according to Markovnikov rule, but H plus is going to attack on which carbon? Carbon atom 1 or carbon atom 2. So beta it is going to attack on that double bonded carbon, the carbon which will have more number of hydrogen. So first pi bond shifted here, C negative will take out H plus. I got the positive charge here. Let me write beta here. This is there. CS2 becomes CS3 and positive part. Beta, it is a which degree carbocation? 2 degree. Is it possible to rearrange from 2 degree to 3 degree? No sir, 2 degree is enough. And now Cl minus will attack here and I am getting here 2 chloropropane. Beta, one more possibility is that it may have CS2, CS2, Cl. Beta, this is a Markovnikov product and this is a what you can say one more byproduct will get. But this one is the minor and this one is the major. Beta, major is why? Because it follow the rule called as a what? Markovnikov rule. Don't worry beta, I'll tell you some more detailed part of it. Please take a screenshot of it. Is it clear? Very good, very good, very good. Now, now, sir, Markovnikov rule is applicable with a unsymmetrical alkene. Let me tell you, Markovnikov rule is applicable for unsymmetrical alkene addition of hydrogen halide. But a hydrogen halide means it should be HCl, it should be HBr, it should be HI, right beta? But we won't get the HI reaction and all. And we are forming here as a alkyl halide. But it follow the rule called as a what? Markovnikov rule. But if the unsymmetrical alkene and we are adding HBr, we are adding beta HBr in presence of peroxide, sir, it follows anti-Markovnikov rule. And then we are getting here as a alkyl halide. So what is the anti-Markovnikov rule? Let me discuss with you beta. आप इसका screenshot ले लिए वेरी गुड. अब देखिए बेटा अनसिमेट्रिकल अल्कीन विथ HBr बड़ा इंटरेस्टिंग पार्ट है. सर दिस इज CH3 CH double bond CH2 unsymmetrical alkene. I am adding HBr beta in presence of peroxide. Sir, it follow the anti-Markovnikov rule. What is that? Positive part of the attacking reagent attaches itself to that double bonded carbon, the carbon having less number of hydrogen. So these C will attack with the H and Br will attack here. I will get CH3, CH2, CH2, Br. This one is the major and other part beta CH3CHBr and CH3, this one is the minor. So remember beta, if addition of alkyl halide we are doing on unsymmetrical alkene, be check with that. Either you are adding the HBr in absence of peroxide or presence of peroxide. Presence of peroxide, anti-Markovnikov rule we got here, and same thing I want to write CH3 CH double bond CH2 and HBr, but no peroxide means it should follow Markovnikov rule, and I am getting CH3 CH CH3 Br, that one is the major, and other part beta CH3 CH2 CH2 Br, and that one is a minor. See beta, this is a minor here, but that is a major here. This is a minor here, but it is a major here. Only because of the rule followed by it, that is anti-Markovnikov and Markovnikov rule. Is it clear beta? Or are you having doubt in this one? Please, you can ask me your doubts here. No doubt. Very good. Chalo, I want to give an example because ये most important part in haloalkane haloarenes. Very important. Chalo, I want to ask you, try to do this one. Sir, CH3 CH double bond CH2. Sir, addition of HBr, addition of HCl in presence of peroxide, addition of HCl in presence of peroxide. दो बार हो गया HBr peroxide. बेटा मैंने बताया था any unsymmetrical alkene when you are going to add the hydrogen halide in presence of peroxide, but peroxide with only HBr, it should be anti-Markovnikov rule. But whatever the peroxide and we are using any hydrogen halide but other than HBr, it is always follows Markovnikov rule, Markovnikov rule, Markovnikov rule. But here anti-Markovnikov rule, because anti-Markovnikov rule which means that will be only applicable for addition of HBr with peroxide on the unsymmetrical alkene. So with this one beta Markovnikov rule major product what I will get CH3 CH CH3 Cl CH3 CH CH3 Br, beta major peroxide doesn't matter Markovnikov only CH3 CH Cl CH3, beta here HBr peroxide then only anti-Markovnikov CH3 CH2 CH2 Br. Is it clear sir? Very good. Very good. Take a screenshot, sir. Very good, beta. Because in haloalkane and haloarenes, most of the question in IIT level, even in the NEET, they are asking from this topic only. Most of the children are getting confusion over it. Beta, let me know what you want to follow. It is an unsymmetrical alkene, beta. This is an unsymmetrical alkene. I am adding HBr in presence of peroxide. Can you tell me, sir, it is a Markovnikov or anti-Markovnikov? Yes, very good. Sir, it will follow anti-Markovnikov rule. Says that addition of positive part will attaches on that double bonded carbon which will have less number of hydrogen. Anti na beta. The positive part will attaches on that double bonded carbon which will have less number of hydrogen. But how many hydrogens are here? No. Here how many? One. Correct? H will attack here, so Br should attack here. I will get methyl. Hu add, doesn't add, no need to bother because we know carbon valency 4. 1, 2, 3 and 1 H. 1, 2, 3 and 1 more H. We got the product. But if same thing is there, right? Let me tell you. Same thing because children should not get confusion over it. Na beta. Sir, it is an unsymmetrical alkene. I am adding HBr. Beta, no peroxide. Sir, Markovnikov rule. Positive part of the attacking reagent attaches itself to that double bonded carbon, carbon having more number of hydrogen. H come here, Br comes here. Sir, this is the product. Beta, any doubt till here? Right? Take a screenshot, sir. Take a screenshot. Very good, beta. Over. Very good. Beta, now addition of hydrogen halide is a first case we have seen here from alkene. Mein. Beta, one more is that addition of these halogens we'll take. Second one now. Alkene only. But addition of what? Halogens. Beta, interesting part this one, you know. Why? Let me tell you. Sir, if we are having CH2 double bond CH2, I want to add halogen in presence of a non-polar solvent like a carbon tetrachloride. What will get beta? One halogen on this carbon, other halogen on this carbon, and we can say 1, 2 dibromoethane. Wait, I will tell you one more thing here. But addition of halogen into the alkene in presence of carbon tetrachloride. Is it clear? Carbon tetrachloride non-polar solvent. We are getting beta addition of halogen on both the side called as a 1, 2 dibromoethane. Please note down this one. Sir, if we are having unsymmetrical alkene, arey wah. I want to add halogen in presence of carbon tetrachloride. Obviously, one bromine here, one bromine here. I'll get CH3, CH, then CH2, then Br, and then Br, 1, 2 dibromo propane. Any doubts sir till here? Please note down beta fast. Chalo, right, beta? So addition of halogens to the unsymmetrical alkene, sorry, addition of halogens, addition of halogens to the symmetrical and unsymmetrical alkene in presence of carbon tetrachloride, we got the that is a dihalo product, right, beta? So these are the four methods are there we have seen. Then the next one is method number E, halogen exchange. Very good, beta, and very important in point of view to prepare the alkyl fluoride and alkyl iodide. E, beta, E, and this method is called as a halogen exchange method, right, beta? In lab it is not possible to prepare the alkyl fluoride and alkyl iodide easily, but halogen exchange method is a method help us to prepare or help us to get the alkyl iodide and alkyl fluoride. Check it here. For this halogen exchange, the first one called as a what? Finkelstein reaction. How da? Finkelstein reactions. Sir, how we know Finkelstein reaction, beta? For that one, just you should remember the reagent. The reagent should be NiI with a dry acetone. Khatam. If this reagent is there, Finkelstein. Go with examples, sir. Sir, alkyl halide plus NaI in presence of dry acetone. Sir, what we got? NX came out. I got alkyl iodide. Is it clear, sir? Sir, what could be the X? Either it is a chloride or bromide. Fluoride, we cannot take it here. Is it clear, beta? Now we can make, sir. What is that? CS3Cl. I got CS3I. C2H5Br. I got C2H5I. Because everywhere iodine is coming from here, NX can be replaced. Is it clear? Finkelstein reaction, beta. Do you want any example of this one? We can take any example your wish. Sir, in place of this example, I want to write alkyl chloride. I want to write alkyl bromide in presence of dry acetone with what? NaI. Right, beta? Dry acetone. What we got? Ri. Here, Ri. Remaining byproduct NaCl. Remaining byproduct NaBr. But a Finkelstein method is a reaction which helps us to get the alkyl iodide. Reagent should be NaI with a dry acetone. Is it clear? Sir, is it clear? Very good, sir. But a second method, halogen exchange, that will be called as a Swartz reaction. But in this one, we are able to prepare only alkyl fluoride. Means Rx in presence of heavy metal fluoride. What is that? Silver fluoride. Hg2F2, mercurous fluoride. हाँ बेटा, cobalt fluoride, antimony fluoride also we can take beta, SbF3 antimony fluoride. So they all are the metal fluoride, heavy metal fluoride. Making to react with Rx, sir, I am going to get Rf, remaining is AgX out. Sir, can we go with example? हाँ भाई. What could be the X, sir? सोचो बेटा, what could be the X? Sir, it may be chloro or bromo because we cannot take iodo as it is a slow and reversible, and we cannot take the fluoro as it is a explosive, so it is the only method. So what we can say, sir, it is a methyl chloride or methyl bromide, but I'm making it to react with a what? Heavy metal fluoride, any heavy metal fluoride, Hg2F2. Sir, what we got here as a methyl fluoride, what we got here as a methyl fluoride, remaining is what? AgCl. Remaining is what? AgBr. Is it clear, beta? These are the few halogen exchange method which help us to go with a method of preparation of alkyl haloalkane. Right, beta? We did about haloalkane. Now come for the preparation. See, beta, first method we saw classification. Second is nomenclature. Third is preparation. And now physical properties. Come for the fourth method or topic 4, that is the physical properties of alkyl halide. Sir, now physical properties of alkyl halide. Physical properties of alkyl halide. First one. First one. Solubility. See beta. Solubility. What is there in the solubility? You know beta. Alkyl halide. You know alkyl halide means R and X. X is more electronegative than this R. It will get the partial negative. It will get the partial positive. I should say the molecule is a polar molecule. तो बेटा what is that alkyl halide में alkyl halide though it is polar, see here, alkyl halide though it is polar, है ना, still it is polar, though it is polar, it is insoluble in water. Yeah beta, it is insoluble in water because it cannot form hydrogen bond with a water molecule. That means the compound which has a tendency to form a hydrogen bond with a water molecule only can be soluble in a water. But here, alkyl halide, though it is a polar beta, it does not have a tendency to form the hydrogen bond with a water molecule. So they are insoluble with a water molecule. I wrote the same thing. Alkyl halide, though it is a polar, it is insoluble in what? Water molecule. That means it does not have a tendency to form hydrogen bond with a water molecule. Is it clear, sir? Very good, beta. Second point we'll write, beta. Sir, density. Beta, now see if it is a alkyl halide. Beta, if atomic mass of halogen increases, density increases. Beta, if the number of atoms of the carbon increases, density increases. So what I should write, beta? Density increases with the increase in the, I should write now here. Density increases with increase in what beta? Number of halogen atom you can say. Number of carbon atom we can say. Right? Or the atomic mass of halogen we can say. So density increases with increase in number of carbon atoms, number of halogen atoms, and atomic mass of halogen atoms. See example beta here. CH3, CH2. Got the point? Beta CH3, CH2, Cl. Sir, CH3, CH, CH3, Cl. Beta halogen is same, but number of carbon atom here 2, here 3. So this is the order of what? Density. Beta number of halogen atoms here. CH3, CH2, Cl. Sir, CH3, CH, Cl, Cl. Number of halogen 2. Density increases. Sir, atomic mass. Beta CH3, CH2, Cl and CH3, CH2, Br. Bromine atomic mass greater than Cl. So density increases. Is it clear, beta? As the number of carbon atom increases, density increases. As the number of halogen atom increases, density increases. As the atomic mass of halogen increases, density also increases. Is it clear? Write down, beta. But an important property will come for the boiling point in this haloalkane, right? Solubility, density doesn't matter. Everybody knows about that. But important questions, even in IIT, even in NEET, they want to ask from boiling point. Try to understand this concept, but a very simple way. Very simple way. The property number 3 called as a boiling point. See, beta, it is a alkyl halide. Partial negative, partial positive. We got the polarity. As we got the polarity means what will be there, beta? I will show you. Sir, it is a R and X. Are you getting beta? Alkyl halide only. So it will get partial positive, it will get partial negative. But in between negative positive, we are having a force of attraction. But in between positive negative, we are having a force of attraction. But this force of attraction called as a what? Van der Waals force of attraction. But I think you know the 5 van der Waals type of force of attractions are there. Among that, the force of attraction, what we learn in states of matter is what? You know, dipole-dipole interaction, induced dipole interaction called as a what? London dispersion force. All these things come here. So I should say about boiling point, beta. Haloalkanes have higher boiling point. I'll write here. Haloalkanes are having higher boiling point that of that of corresponding alkane. हाँ बेटा, it is a alkyl halide. I will take here alkane and alkane. Corresponding alkane means their molecular mass will be nearly same. Corresponding alkane. So if you want to compare this haloalkane and your alkane, those molecular mass will be same. So which is having higher boiling point? Beta haloalkane. Why? Because alkyl halide is a polar and haloalkane is a non-polar. No polarity will develop between the carbon hydrogen in the haloalkane. So what we can say, beta, haloalkanes are having a higher boiling point than those of alkane because it is due to their polarity. Because it is due to their, beta, their मतलब alkyl halide मतलब haloalkane. So it is due to their polarity, and actually we should not write the U strong, but the force of attraction between dipole and induced dipole will be more. So and strong dipole dipole interaction. But try to understand dipole means what? Haloalkane, two different pole plus minus, two different pole plus minus. So dipole is there, and interaction between this dipole called as a what? Dipole interaction. Is it clear, beta? Yes. Due to their polarity and strong dipole interaction between haloalkane molecules, between haloalkane molecules, right? But one example or one sub point I want to write. Suppose I am having alkyl halide, but I am having a same alkyl group. The boiling point of haloalkane decreases in the order of what? Let me tell you one example. I want to write boiling point order. See, beta, Ri, Rbr, and Rcl. What is that? Same alkyl group. And they are asking order of boiling point. Check beta boiling point ki order. What is that? Boiling point of the order will be decreases in this case. Why beta? Because the mass will be decreases, right? So I should say this is the order of boiling point. So that means can we say boiling point is greater for iodine and smaller for chlorine? Boiling point will be directly proportional to size of atom, because larger the size, larger the van der Waals force of attraction, beta. Greater the size, greater the van der Waals force of attraction. हाँ बेटा, greater the size, greater the surface area, greater the surface area, more the interaction, greater the boiling point. That means larger the size, greater the van der Waals force of attraction. That means greater the surface area. Directly proportional. But a surface area greater means that should be straight chain. Kada? So larger the chain we can say, greater the straight chain also we can say, or larger the straight chain we can say. Is it clear? One second, one second, one second. Right. So once again, but I want to discuss here. What is that? Boiling point where haloalkane and alkane, if you compare the molar mass will be same. So which is having greater boiling point? Haloalkane. Because because they have a tendency, means they are polarity, having a polarity and strong dipole-dipole interaction. See beta, it is a alkyl halide. We are having two different pole, two different pole. In between two different pole, they are having a some kind of interaction. So due to this dipole-dipole interaction and having a polarity, haloalkanes are having higher boiling point than the alkane. First point. Second point, I should say, beta Ri, Rbr, RCl, where R is the alkyl group, same alkyl group. It is a boiling point order, indicate that iodine is larger in size than chlorine. But a larger the size, larger the van der Waals force of attraction, greater the surface area. Got the point? So larger the iodine means what we can say, directly proportional to molar mass also. But among chlorine and iodine, iodine will have larger molar mass. So greater the molar mass, greater the boiling point. Greater the surface area, greater the boiling point. Greater the size, greater the van der Waals force of attraction, greater the boiling point. That means inversely proportional to branched. But if the compound is having more number of branches, compound is having more number of branches, less the boiling point, less the branches, more the boiling point. That is we are going to see in the isomeric alkyl halide. Please take a note up to here. Take a screenshot up to here, beta. Please take a screenshot up to here. Is it correct? Right. I will tell you. One second, beta. I will tell you. One example is here. One example I will tell you. Is it clear? Good. But I will write all these things as it is. I will keep here because I want the boiling point only. Remaining one I don't want. See here now. Examples I want to draw. So we are having some compounds are there. Let us say CH3I, CH3Br, have it CH3Cl and CH3F. Sir, get the boiling point order. R same. Iodine molar mass greater. It is the order of boiling point. Clear, sir? Very good, beta. Chalo, one more we'll see now. Sir, it is a alkyl halide. Sir, this is also the alkyl halide. How beta? C2H5 means that one. Beta, it is a alkyl halide and it is the alkyl halide C4H9. Beta, CH3, here CH3, CH2, here CH3, CH2, CH2, here CH3, CH2, CH2, and then Cl. But what did you say here? I know larger the surface area, larger the surface area, greater the boiling point. Sir, how you know larger surface area? But a C4H9 can be written as 1, 2, 3, and 4. 1, 2, 3, 4, C4. 3 plus 2, 5 plus 2, 7 plus 2, 9. So larger the surface area, greater the van der Waals force of attraction, greater the van der Waals force of attraction, greater the boiling point than the others. Is it clear, sir? Is it clear, sir? Is it clear, sir? Very good, beta. Very good. Now, sir, I am having N butyl bromide. Sir, I am having iso butyl bromide. Sir, I am having tertiary butyl bromide and I want boiling point order. Beta N butyl larger surface area. Iso one branch, tertiary more branch, greater the branch, less the boiling point. It is the order of boiling point. See beta, N-butyl, larger surface area, straight chain, no branching, greater the boiling point. Tertiary, branching, more the branch, less the boiling point. Is it clear? Very good. Very good. But one example is that CH3Cl compound number A. हाँ बेटा, और CH3Br you take compound number A. Then second case में CHBr3 compound number B. Then CH3Cl compound number C. And then CH2Br2 compound number D. So arrange the following in a increasing order of the boiling point. See beta, carbon 1 every case, okay. Bromine, chlorine, bromine, bromine. Higher molar mass, bromine. Beta, more the molar mass for this one. I should say B will have a greater boiling point than this one. What is that? D. Then beta, only one. That is what? A. Then what is that? C. It is the order of boiling point. Means greater the number of molar mass, greater the boiling point. So CHBr3 will have more boiling point than CH2Br2, than beta CH3Br, than CHBr3. Sorry, than CH3Cl. Clear? Or beta, so this is the concept of the boiling point. This is the concept of the boiling point. Or shall I take out? But all these things boiling point we are seeing only for the what? Haloalkane. Come for the haloarenes also. Interesting part beta haloarenes. Even in exam NCRT में देखिए तो values of these haloarenes. But I am going to give the trick for you the haloarenes. Check it beta. The boiling point of isomeric dihaloalkane are nearly the same. Remember beta. Boiling point of dihaloarenes means aryl halide. Can we say beta it is a isomeric dihaloarenes. So boiling point of these isomeric dihaloarenes, they are nearly same, but their nearly beta, not exactly, but their melting point are quite differ. Sir, in IIT point of view or NEET point of view, is the most important question they used to ask us. Listen, beta, I will tell you what is that. Sir, this is a orthos product.